Good afternoon, everyone. I hope you're all having a good conference and London is treating you well and you're not too hungover after last night. If I've not met you before, hello, my name is Jeremy Davis. I am a developer, architect and all-round problem solver, and I live in the north of England. Perhaps you've come across my blog. I try to write something technical every couple of weeks, which usually ends up being about Sitecore. Or if you were at this event last year, you probably saw photoshops of me spammed all over everybody else's presentations, because some of my friends in the MVP community think that's hilarious. But there's no need for any of that nonsense today, because you lot get the real deal. I work for Google. We are a partner. I no longer have any idea what sort of partner we are, because Sitecore have changed all the rules. But we're based in Cardiff in Wales, and we have some developers up in Manchester and managers in London. We happen to be recruiting if anyone is looking for a job. And since we're a decent-sized company with what I hope is a fairly good pedigree, we seem to pick up our fair share of rescue projects. And thanks to them, I found myself involved in a fair bit of performance consultancy in recent times. And that's got me thinking about the idea of faster code for Sitecore. And it's kind of part of the reason why I'm standing up today giving this talk. But the real origin of this presentation goes back a bit further to a previous job I had when I dealt with my first Sitecore project that really had kind of performance baked into the requirements. The team I was working with won a gig to rebuild a company's website. And fairly early in the discovery for this, the client told us that they had engaged an advertising agency because they wanted to use TV adverts in their relaunch. And I'll be honest, that kind of worried me. And we asked the client what it was they were planning to do, and we spoke to the advertising agency, and they were very excited, as advertising agencies often are, and they told us that they'd bought some great advertising slots, including one in the middle of the final of Britain's Got Talent. And if you're not from the UK, I assume you have some equivalent of this show in your country. Big TV talent competition, famous celebrity judges, probably gets quite high ratings. And my project risk spidey sense was going crazy at this. So we asked the ad agency what they thought this would do to our web traffic. And they were talking about very big numbers and very small timescales. Their response was kind of less of a predicted load graph and more of a scary load roller coaster. And this, unsurprisingly, made me and the team I was working with pretty focused on how we were going to address the performance and the scaling of this project. And we looked at all the normal things that you worry about, like infrastructure for your content delivery clusters and details of config and thinking about things like Cloudflare for edge caching. But on top of all of that, I spent a fair bit of my time looking at the performance of the code that was being committed in the project. And that's really the inspiration behind what I want to talk about today. Because what I learned is that if your predicted load graph looks like a scary fairground ride, you are going to need to measure if you want to go faster. Because come launch day, I think we'd all like to feel like the woman on the right here, or maybe the guy at the back, excited at the prospect of a successful launch. But the reality is that it's actually pretty easy to write code that works okay in your development environment and then falls over pretty hard when you get to production. And when that happens, we end up feeling like the terrified woman on the left here. And I don't think any of us really want that. So over the next 35 minutes or so, I'm going to try and give you a rapid introduction to a few things that you should find useful if you've not looked at the performance of the code you're writing before. I'm going to talk about some very practical things. I've got a kind of video demo of some tools that you can make use of. And I'm going to talk about some fluffier stuff as well. Code patterns that you can use or you might need to avoid, and things you might see in measurement data. And I'll talk a little bit about the kind of project process aspects of this as well, to try and guide you all towards ideas for ending up with more efficient code. If you do come up with any questions during the talk, I'm more than happy to try and answer things, but I'd be grateful if you could keep them all to the end so I can stick to time. I have tried to leave 5 minutes for you at the end. But hopefully all that sounds good to everyone? Yes? Yeah. Awesome, you're in the right room. So, To help illustrate some of the concepts I'm going to talk about, I have created a very simple example site. I think it very clearly demonstrates why no one has let me do front-end development since the early 2000s, but it includes some flaws that are based on problems that I've seen in the real world. I should point out that I've caricatured these a bit to make them nice and obvious, so you are allowed to laugh or cringe, depending on what you feel is appropriate. But let's imagine it's Monday morning, and you come in and you find a message in your inbox that says you need to look at the landing page for some new sales website. Your boss wants you to make sure that it's going to survive a big new advertising campaign. So if you're anything like me, at this point, you probably open up a web browser and click about a bit. And once the site loads up, we can see, well, there's some navigation going on at the top here, and we can click through a few pages, and it looks okay, doesn't it? It's fairly responsive. And back on the home page, there's some sort of advertising banner, and down below it, there's some category things, and we can drill into a category, and there's some more details there, and clicking through down through the details gets you to some sort of sales page. So nothing particularly exciting or earth-shattering. But the word measure is central to what I want to talk about today. So let's start very simply with just the idea of how long does it take to get the HTML for this page? It's an easy starting point, and it also makes a very good reference point to come back to later to see how any changes you've made have improved the situation. How can we do this? Well, the network monitoring features of your browser of choice are a good place to start. So we can open up the dev tools here in Chrome, and when that pops up, make sure that we're on the network tab, and just refresh the page a couple of times, get the bytes flowing across the network. And once it's finished doing that, if I zoom in on the number for how long it took to get the HTML, it's about 300 milliseconds. That's not awesome, but at the same time, it didn't really feel like a crisis. You know, when we clicked about the page, it didn't seem too slow. So this might not set off alarm bells while people are developing. But let's see what we can discover with some more detailed measurement. And we'll start off with Sitecore itself. Because luckily for us, Sitecore includes a fairly useful tool in the form of its debug mode. It's kind of an underappreciated bit of experience editor, I think, but it can give you some really good insight into what your code is doing under the surface to Sitecore. So to get at the debug tools, we fire up Sitecore, and we log in with our super secret admin credentials. Don't steal my password. And once it's loaded, we can go to Experience Editor, and we can expand the ribbon, and then we can click the little Other button to get the drop-down to switch over to Debug View. And that reloads the page, showing us published content now. And if we scroll down, it's added some extra information to the end of the page. If I zoom in a bit, the first thing we can see here is there's a thing it describes as hotspots. And it's kind of a summary of what's working Sitecore the hardest. You get the top 3 things for time taken, for execution, and for the number of items that have been hit. Those summaries get built from the details in the section below it called Profile. And the stuff here is it's the bits that I find the most useful when I'm thinking about code in this way. So I'm going to come back to the details of what all this means in a minute. But I'll quickly point out the third section down below, which is trace data. And that's very like trace in ordinary ASP.NET. It's just a set of messages that show the flow of execution of your page, and there's a line or two for each step that's going on, and there's some timing data put alongside it, showing how long that step took and how long since the beginning of the page. But if I go back to the profile section, what is this telling us? Well, first of all, you get a little visualization of how long each of these things took relative to the others, with some percentages and little bar chart things. Alongside that, you get the name of whatever thing has happened. Note that there's some indenting there, which tells you about where there are kind of child operations going on because of placeholders. And then you get timing details. The total column tells you how long this step plus any children it has took to run. And the own column tells you how long that step took on its own. And then the remaining 4 columns tell you about the effect each component had on Sitecore's data layer. They're not labeled to explain this, but I think they work with the same kind of statistics as the total column. So first up, there's items read, and that tells you how many content items have been accessed. And that's including both the things that you've asked for explicitly, so queries that your code has made, as well as things that Sitecore needs on its own, like placeholder settings or rendering definitions items and things like that. The data cache hits and data cache misses column tell you about whether this data has come out of the caching layer in Sitecore or not. And then physical reads tells you about how many network operations happen to go and talk to the database to get data that wasn't in memory. So this tells us quite a lot about what's going on under the surface. We can see at the top that resolving devices and aliases and things like that is all pretty efficient on this page. And most of the UI components seem okay. The header and the hero banner and the footer all seem to have fairly small numbers. The layout looks a bit iffy though. It doesn't hit many items when you account for the children underneath it, but it does take quite a lot of time, it looks. So I'm going to come back to that one in a bit. But down at the bottom, this color category listing component, it's hogging about 20% of the time for the page, and it's hitting 6,000 items. That looks worth investigating, because that's a number that certainly makes me think that this isn't going to scale well. So let's switch across to Visual Studio and try and work out why. Opening the view file for that component in Visual Studio shows that it's a fairly ordinary glass view. There's nothing special going on there. But I'm a little bit confused about the if statement that's sitting in the middle of this. It kind of looks like that's throwing away some data that got returned by the model, and that seems like it might be a bit of a code smell. So let's have a look at the model and see why. And we can use go to definition in Visual Studio to just navigate across, and hopefully your toes curled up when that appeared on the screen. Because this model, it turns out, has a rather nasty descendants query in it. Perhaps that if clause is throwing away data that should never have come back in the query in the first place. Now, sadly, this is actually a depressingly common pattern in real-world code because it's really easy to write expensive queries. And they often don't really behave like a problem until your site is under load or has the full content tree when the client's finished setting up their production site. What can we do to fix this? Well, for decent performance, models should query just the data you need and nothing else. And wherever you can, avoid descendants queries because they can get very expensive very quickly. So for minimal change, let's just stick a templates clause in there to make sure we only get back the items we needed, and change the query so it's returning the children but not the descendants, because with my psychic debugging hat on, I happen to know that's what the UI actually wanted. Now, when you make a change, you should rebuild and redeploy and measure it again to compare, because you need to know whether the change you made actually improved the situation. When you do that through this view, you do have to refresh the page twice after you've made a change because the stats get skewed the first time while Sitecore's loading back into memory. But after the second one has finished, we can see that that fairly small change makes a pretty big difference. Execution's gone down from 200 milliseconds to 7 milliseconds, and that's because we're down to about 150 items being processed. And that's a pretty big win. Now, key takeaway from this thing here for you guys is it's quite easy to spot where things are going wrong with bad queries and things like that through this debugging tool. Make a point of loading this up and looking at the code you're writing, and try and keep things like execution time, which I'll talk more about in a minute, but specifically items accessed as low as practical. So once you've looked at the code's effect on Sitecore, next up, I tend to start thinking about the server a bit more generally. There are loads of tools that you can use for this, but the ones I come across most often are JetBrains.trace and good old Visual Studio. I'm going to stick with Visual Studio 2017 here, because chances are most of you who are building code are probably using that anyway. I don't think these features are in the free version. If you are running the community license, have a Google for a tool called CodeTrack, which is an open source equivalent of quite a lot of what I'm going to show here. Also, Microsoft have slightly shot me in the foot here by releasing Visual Studio 2019 on Tuesday, I think it was. Some of the UI for that has changed a bit The features are the same, but the menu items have moved around. I plan to write a blog post about what has moved when I get a few minutes. So before I mentioned that the debug timing data looked a bit odd for the layout. So let's stick the source up for that. It's another glass view, but we noted earlier that it wasn't really hitting too many items, so chances are the model is not going to be massively of interest to us here. There's some placeholders, and there's some stuff that looks a bit like extension methods. But there's nothing here that's shouting problem. So to look a bit further under the surface, let's have a look at what Visual Studio's performance profiling has to say. To get started with that, first thing we need to do is switch over to a release build, because Microsoft's documentation says that you get best results from this tool if you're profiling release code. So we'll rebuild and redeploy and reload the site. While it's doing that, bear in mind that you really do need to deploy your PDB files when you're doing this, because the statistics you get can be quite hard to read if you don't have all the symbol data available. But once that's finished, we can use the debug menu and the profiler performance explorer menu to start a new performance session. And I've stuck up the properties of the session on the screen, because if you happen to use virtualization technology or Docker or something like that, anything hypervisor based, then you may need to make a config change here. By default, this tool does its data gathering with something called instrumentation profiling. It's accurate, but for some reason it doesn't play nicely with some hypervisors. If you hit this issue, you get a weird dialog box popping up when you start the profiler that says, connecting in %1 mode when monitor was running in %2 mode. I think the percents are a bug in Visual Studio's error message there. But as soon as you dismiss the dialog box, the profiler just stops and you get no data. Sampling mode, on the other hand, does not rely on whatever features virtual machines don't like. And to be honest, the extra accuracy is probably not important to us here. So I happen to be using a virtual machine, so I'm going to switch. And then we can just use the attach option for the performance session to attach it to our website application. Like attaching the debugger, you need to make sure you pick the right process for Sitecore and don't accidentally connect to Xconnect or Identity Server. So I tend to expand the username column because that's one of the easiest ways of spotting the right one. And you probably need to make sure that these two checkboxes that I've highlighted here are ticked and that you're running as an administrator to be able to see the processes you want to attach to. But once that's done, you can attach, and the profiler starts with this little animation. And then you just switch back to the code you're running and exercise the thing you want to profile. So just refresh the page a few times here, and then click the tiny little stop link, which is probably not very easy to read there. But once it does that, it starts generating a report for you. It can take a while, so I've sped up the video a bit here. But after it's finished thinking, what you get is a nice little report summary. There's a graph that tells you about the overall CPU usage. There's a hot path analysis of what bits of your app domain are working hardest from an inclusive perspective, so including the child methods that they're calling into. And there's a list of the functions that do the most work from an exclusive perspective. But to be honest, I don't find this view particularly helpful looking at website code, because the stuff that appears here, unless you've done something really wrong, is usually just Sitecore or .NET itself. So you can use a little drop down at the top of this report labeled Current View to change to, well, I tend to pick the Modules view, which basically just lists out all the DLLs in your app, and you can sort it by inclusive samples I picked here to put the hardest working stuff at the top. And when we look down that list, we can kind of see my namespace is a bit high up here, which is a bad sign, and that current language helper that we saw in the view file seems to be doing quite a lot of work. Zooming in, it's about 1/3 of the execution time here. So that seems like an obvious thing to go and look at the detail of. And you can right-click on a particular function here and use Show Function Details from the menu to get a more detailed view. And when that pops up, you get a little call tree across the top, and you get a little snippet of the hot path analysis, which nicely highlights another problem for us here, that someone has left some ridiculous code lying around. It's not easy to see it, but there is a tiny little link back to your source file here, so we can click on that. and we can go back and we can do some highly complicated refactoring. In the real world, you may need to spend slightly longer fixing your problems, but this is a demo, so I'm cheating. But once you've done that, again, you need to rebuild and redeploy and reload and so on and check the results. While it's thinking about that, quite an important point to make is that when you detach this profiler from the application, it dumps your application out of memory. It does that because Visual Studio injects some custom code into your app domain in order to do its measurements, and it doesn't want to leave that lying around after it's finished because it might mess up your site. And the only way to unload code in .NET is to unload the app domain. So don't run these tests against sites that other people are relying on because they will not thank you for it. So when it's finished thinking through the report generation here, as I'm talking slightly faster than my video, we can go back to the modules view and we can resort in the same way and compare with the results we saw previously. And now when we look down the list, our namespace has gone significantly further down, which is a good sign. And zooming in on the numbers, well, it's under 1% now. Big win, much better. So what does all this tell us? Well, the code profiler is very helpful at spotting places in your application that are working the processor hardest. Visual Studio takes a very numbers-based approach to this. If your brain prefers pretty graphs and nice pictures and stuff, you might find that .trace works better for you. But either way, it's giving you a convenient method of just ranking the effort of running your code so you can spot the things that are not doing so well. And you want your code as far down these lists as you can get it. Now there's another thing that Visual Studio can help us with, and that's the memory consumption of our site. There's two sides to memory consumption. There's whether you have any leaks going on where effectively you're stopping the garbage collector from tidying up after you properly, or where you're creating and destroying large amounts of stuff which just makes extra work for the garbage collector and therefore uses up more processor time. And Visual Studio's debugger can give us some quite helpful hints about what's going on with both of these. Hopefully you are all used to the idea of just attaching the debugger to your website in order to look at some code. And you will be used to the idea that when you do attach the debugger, Visual Studio gives you some little animated graphs of what's going on. And the top one here is a little graph of process memory, if I zoom in on that. And that graph in itself is actually quite helpful because it gives you quite a visual way of looking at trends. It's kind of roughly flat over time. You're probably in a reasonable place. If you start seeing it going up even after the little tick marks for garbage collection, or if you see a rise and a garbage collection and it drops and then it starts going back up again in a kind of sawtooth, those can be indications that there might be something dodgy going on. But the graph doesn't really tell us about what's causing the problems under the surface. You can get more detail out of Visual Studio. If you look down below the graphs, there is a little tab called Memory Usage with a camera icon. I realize I messed up my screen grabs here, and I cropped the word usage off the side of that tab, but it does say memory usage. And when you click that camera icon, Visual Studio takes a snapshot of the state of the .NET heap and basically measures everything that's going on in the used memory at this point. And that detail can be very useful for seeing what happens over time because you can compare these snapshots together. So let's take a snapshot now in the kind of the starting state of our application. And it'll think for a while because it gathers quite a lot of data. But what it gives you is a little line to say, taken a snapshot at a certain time and so much memory was being used and there were so many things on the heap. And then we can do some work, refresh our page again to get some stuff going on, and take a second snapshot. And when that pops up after it's finished thinking, immediately you can see that next to the first set of numbers you get some basically diffs to say whether it went up or down, and there's a nice little colorful icon to give you a clue as to whether things got better or worse. But what actually made the difference there? Well, you can click on these snapshots to drill down and see the detail of what data got captured. It takes a few seconds in the real world to process some of that data into a nice table, but you end up with a report that shows you the types that were on the heap. It tells you how many of each of these objects are in memory at this point. And it tells you about the size of these objects, both the space that the object's occupying on its own and the other things it references as a kind of inclusive size. And up at the top of the report, you also get an option for comparing this data to another snapshot, which will turn all these numbers into deltas again, so you can see exactly what's gone up and what's gone down. And there's a search box if you're looking for particular types. But as with what we saw before, a quick way to look for issues here is basically just to sort this. And in this case, if we sort by object size, what do we see? Well, having an object from one of your namespaces near the top of the list is a bit of a code smell, even if the object does have a silly name. So you can right-click on types here and use go to definition again to find the source. And that shows us that, yes, indeed, there is an object here that is clearly wasting a chunk of memory for us. And again, you can then use tools like find references to go and see what's being done with the objects that were on the heap. And it's not very easy to read, but there is a kind of add to collection thing going on at the bottom, which seems like a good place to look. And yeah, when I look at that, again, it's pretty useless code, but it is another example of a pattern that I've seen in the wild. Objects being added to static collections can be a easy cause of memory leaks because statics last for the entire lifetime of your app domain. So this stuff doesn't get tidied up after you when the page execution finishes, and hence memory usage will tend to rise. So we'll stop the app, we'll apply another highly complex optimization in order to fix the memory issue, and then do another test cycle, but this time at a lot of time compression because you don't really want to watch that again. Though you probably can see in the background that the graph looks a bit flatter this time. And when we resort the report in the same way as before, that type has now dropped off the list completely. And that's much better news for our application. Now, if I stop the debugger, there is one final test to round out the demo here. And that's to retest that response time that we looked at initially. So with the debugger detached, we can open up the network monitor again and do the same trick of just refreshing the page and then going and looking at the number that it comes up with. And that's dropped down to 36 milliseconds now. That's a bit better. I reckon our imaginary boss would probably be pretty pleased with that. And as a result, the site stands a much better chance of surviving load that's thrown at it in production, because we found and removed 3 fairly obvious problems. And with that, I'm going to move away from the video and just talk a bit more about some of those code and data patterns that came up there, because there's a few other things that I'd quite like to emphasize. The first pattern I mentioned in the demo is where you see components that load lots of items. I'd argue that really, if you're seeing stuff in your own code that's loading more than 200, you'd probably want to have a look, and anything over 1,000, you almost certainly have an issue to address. We talked about the idea of writing more specific queries, but there are usually different approaches to solving problems, and when you need to deal with larger numbers of items, content search APIs are your friend, especially in that scenario where you need to search down a tree to do something like a descendants query, because they are much faster at dealing with that. Also, potentially, content search can be used to remove the need to actually load items through the Sitecore data APIs entirely. If you're able to mark fields in that your UI needs are stored in your index, you can get that data back straight from the search index without having to do an item load. And when you're dealing with large numbers of items, that can potentially be significantly faster. But there's a balancing act here, as there are with many aspects of code, that the more you store, the bigger your index gets, the more time you spend building it. So this is another point about why the measurement comes in. Apply approaches like this in places where your measurement data tells you you'll get most benefit from it. We also saw situations where one component used a big chunk of execution time. You need to think a bit relatively with stuff like this, because if you have a component taking 30 milliseconds on a page that takes 40, chances are that's probably going to be all right. One that takes 300 milliseconds on a page that takes 400, that's starting to seem more like a problem. When you find slow components, compare the data that Sitecore can give you about the effort that's going on with the data that Visual Studio can give you. Is it slow because of complicated algorithms, or is it slow because it's loading lots of items? the measurements tend to point you in a sensible direction for where to put your optimizations. But it is worth remembering that sometimes your client will just give you difficult business rules. And in cases where make it run faster isn't practical for some reason, you probably want to start thinking about whether you can make that code run less often. And the best way to deal with that in most situations is to start thinking about caching. Which brings me to the next point, which is that where you have components that have got behavior and no output caching going on, they are probably good targets for a bit of performance improvement. I quite often come across developers when I do consultancy engagements that say things like, but I can't cache my navigation component because the designers have put this kind of user greeting thing in it, and that means the data is different for everyone. To which my response is normally, is it not possible to break these things apart somehow? I strongly suspect I should be writing another talk on topics like this, but the idea that you can refactor your UI into components that deal with layout and components that deal with logic and break these things up with a kind of helixy flavor to them, gives you the best chance of applying the right caching settings to the right things. You can refactor the structure of UI for performance in kind of the same way that you'd refactor code for performance. Again, though, there's caveats here that the more you come to rely on caching, the more expensive publishes become, and you probably do find yourself having to educate editors that spamming on the publish button is not good for their production site. But you know, that's probably not just an issue for this situation. So what about things to do with the CPU and memory then? Because that's some Sitecore related stuff. First thing to call out here, I hope, is a kind of obvious one, that if you're seeing processor usage graphs that basically look like a big solid rectangle when you're testing in development, you're working your processor too hard. And this is stuff that's probably not going to scale when you start throwing more load and more performance more items at it. So, can you change algorithms to be more efficient? Can you apply caching so that the code only has to work hard occasionally? Or can you kind of find a halfway house of maybe pre-computing some bits of the data and stashing them away somewhere? A fairly common pattern here is things like computed search index fields. You can trade off processing time when you're building indexes against processing time when you're rendering your UI out to the public. And sometimes that can be very helpful. Second thing is when your CPU graph looks like the top of a castle wall, or a square wave if you're feeling more like a scientist than a historian today. This shows you that your CPU is doing a big chunk of work and then it's waiting for something to happen. And 99% of the time, any waiting that's going on here is going to be to do with I/O operations. Because fundamentally, stuff that has to go outside your processor and outside your server is going to take a lot longer than things that happen inside the CPU. And a fairly common cause of this problem these days is the microservice all the things design pattern. When you push things out to an external service, that network operation to talk to it is going to take time. And if lots of that is happening inside UI components, they are going to get slower. Addressing this is sometimes a bit more challenging. It would be nice to say, well, let's make the controller async so that we can fill up those gaps in the CPU usage. But that doesn't work, unfortunately, with controller renderings. Caching is another opportunity here, perhaps, the ability to cache service responses if they're data that you can hold in memory and not requery. But another tactic that sometimes works quite well is to push the service operations out to client side. If this is a thing that can happen, the request can be made from the user's browser rather than from your server, you're taking that waiting issue away from your backend code. And you're probably also making the output of your component more cacheable because you're probably taking out the stuff that's user specific at that point. So there might be two wins in one there. And then last up, there's the whole rising memory graph thing that we mentioned. If your memory usage is going up over time, you need to start thinking about what your code is doing with objects. I talked about the idea of things being pinned in memory before, but there are other issues that can be a challenge here. Building custom caching on top of Sitecore is a fairly common reason for lots of memory getting soaked up. And cache invalidation is one of the hard things in IT, so it's quite easy to shoot yourself in the foot there. String manipulations is another common problem in .NET because strings are immutable, and every time you add two strings together, that's a couple of garbage collection operations. So if your code needs to build up strings, think seriously about whether string builders will help rather than just adding stuff up. Though do measure that one because .NET internally does quite a lot of optimization, so sometimes string builder is not actually faster. And another issue can be choosing the wrong lifetimes for objects that are owned by dependency injection frameworks. So look at the patterns of what changes are happening in memory usage over time, see what's growing and what's churning, and use that data that the tools are giving you to guide your optimization. So the last thing I wanted to cover is a little bit that's more process related, because everything I've talked about so far has been fairly technical, but I want to emphasize that people and the way you work can sometimes be quite helpful here too. If you all walk out of the room with only one thing stuck in your head, I would like it to be that making measuring your code part of your day-to-day development process is a really good thing to do. Simple checks like just turning on the debug mode, as I showed at the beginning of the demo, before you commit something can help you, not be in the situation of accidentally committing a terrible query. We all know, hopefully, that the earlier you catch logic bugs, the cheaper and easier they are to fix. It's kind of the same with performance. It's much easier to fix it when you first start than it is after it's gone to production and there's all that deployment overhead's gone on. And fundamentally, the only worthwhile proof of whether you've made anything better or not is to have a measurement from before and a measurement from after and be able to compare the two and see what is different. But like everything in IT, there is a balancing act here. And I would argue that you should try not to overthink performance before you've actually done some measurement. I fairly often hear clients saying things like, well, in sprint planning, we realized that feature X was going to be a terrible performance issue, so we put some custom caching on our backlog straight away. My clients are weirdly posh. And all too often, this leads to just optimizing the wrong things or making what you think is an optimization that actually makes the situation worse somehow. You've probably heard agile and test-driven development people talking about the idea that when you write code, you should make it work and then refactor it to be pretty and maintainable. Performance is kind of the same thing, I'd argue. First, make the thing work, then measure it, and look and see whether it is causing performance challenges. And that means that you can focus on making the right stuff faster. And your measurements that you're taking are proving your success. But I would argue that you should think about test content early on in your process. I've seen quite a lot of projects that only ever try to do any sort of proper performance testing right at the end when the client finally delivers the last of the real content. And that's kind of the opposite of finding your problems early. But at the beginning of your project, hopefully the people on your team who work on information architecture, or maybe the client themselves, will have an idea of the likely scale of your final content and the structures it's going to be involved in. So I would recommend installing something like PowerShell extensions and just use some script to generate lorem ipsum items at the right scale and structure when you're doing early testing, so you can actually see how the code deals with what the scale the site's going to have when it gets to production. Because that way the testing you do is more meaningful and you don't get surprised by how big the content is when you do get to production. Right then, that kind of brings me to the end of my fire hose of measurement and performance information. So summing up very briefly, we've walked through some hopefully fairly simple examples of how you can spot issues with tools that hopefully you already have to hand. I think I've made my imaginary boss a bit happier because those tools have highlighted some problems for us and they've allowed us to prove that changes that were made to the code actually made the situation better. And we've talked about some patterns that you might see and some ideas that can guide thinking. And my number one takeaway of making time in your working day to try and measure stuff regularly, because it helps you find the problems and fix them, before they become your launch day crisis, and that way you get to enjoy the launch party. So, thank you all very much for your attention. We do, as I hoped, have about 5 minutes left for questions, if anyone wants to ask anything. Somebody will have a microphone to run around and point things. It's the MVP heckle squad on the front row. Yes, mate.
So Sitecore has the profiling context that basically enables you to also add custom sections in the Sitecore debugger.
Yes.
In what situations do you prefer to use that, and which situations do you kind of shy away from adding that to your code? And will you ever deploy code with it?
Historically, I have used that where I've needed complicated logic. If it's a simple controller rendering that's mapping a few bits of data together and putting them out on the screen, the out-of-the-box data is probably fine. Where you get into more complicated stuff where maybe you're making a search query and having to join some data with some other system or something, at that point having the more detailed kind of steps of measurement becomes more useful. Right. As for deploying to production, I think to kind of refer back to the sort of stuff that Donovan Brown was talking about the other day with the world of application insights and how the kind of the PaaS model is trying to change the way we think about running these things. Having that stuff in production can sometimes be really useful to you. But there are trade-offs that obviously you're using a bit more effort. But generally, just sticking data on a log shouldn't be too heavy. So I guess I would probably be, if I'm looking at a site that I think is going to be hit hard, that's a point to have a serious think about whether there is a risk in running the extra code or not. But for day-to-day operations, sometimes just leaving it there can give you some good insight into stuff you didn't see early on.
Right. Cool. Thanks.
Hi. Have you run into here?
Sorry, you're going to have to wave it. Gosh, yeah. Screen share.
So have you run maybe to any problems like you feel like the application is running okay in normal kind of scenarios before you deploy the production, but then the load and let's say concurrency issues cause some issues, and how to deal with that, how to find those?
So yes, it is entirely possible for you to go through the sorts of processes that I'm talking about here, and you still to hit issues on production, because you're not running the code on the same computers when you get to production. You can get network issues can become a problem. You could have other processes that are running on the background on a server that weren't on your laptop that suddenly become an issue. And I think it's kind of that. It's dealing with those issues often come back to the concept of the kind of like the application insight style monitoring, or I've forgotten the name. There's a third-party tool that does very detailed production data capture stuff, and it'll come back to me 5 minutes after we leave the room, but New Relic, that's the one, yes. So using things like New Relic on production can help you capture more of that data and spot things that are going on outside of your web process more easily. But there's a licensing cost for that, so it's not necessarily easy, but...
Yeah, first of all, thanks a lot for the presentation. It's been
pleasure.
One of the most interesting ones so far, for me at least. I was just wanted to ask a question about when you're working with large clients with large amounts of content, and I know 90% of the time we are looking at our own source code to figure out what are the gotchas, like you did in this debugging environment, but have you noticed things from the Sitecore side, which you usually would ignore, especially when it comes to large content, because what I would do is take a backup from production, so I have the full set of content, and run it locally. Have you noticed things from the Sitecore pipelines and stuff that maybe doesn't even need to be on the web roles as well? And
so that comes back to my kind of I've talked about a small sliver of a very wide topic here, because I've tried to focus on the idea of things that we can do as developers day to day to try and prevent us causing ourselves problems. I made a brief reference to the idea of when you're doing real projects, there's other streams of work that are important to performance. So production configuration, that you've gone through the documentation and dealt with the idea that there are things that you don't want to run in your CD servers that you can turn off in config and things like that. And most of that stuff is documented, and when you look at instructions for the deployments or things that are talked about in like the swap master to web config that turns off some of the stuff that you don't need when the machine is not an authoring server.
Yeah, but you never needed to like contact Sitecore support and say, look, this
Oh yeah. No, believe me, I've had plenty of sport tickets over things. A weird example from recently, I dealt with a client who had come to Sitecore from MVC, but didn't really know Sitecore, and they had applied a very I'm an MVC developer approach to making their views, so they were very nested and they had lots of kind of partials and things. And in the more recent, I think it's about 8.2 and onwards, there's a change in the way Sitecore processes the MVC Razor data, and it is way slower. And literally we were seeing servers that were stalling because they were 20 or 30 include files, and Sitecore was probing down all the way through the disk for these things, and you still definitely can get problems.
Cool, thank you. And also with that guy's question, you can run Locust locally, so that's like a load testing tool, and use the same stuff.
That's another thread that I've missed. I've not talked about here, is the idea that you can also throw proper load at your code before you go to production, but that's a talk for another day, I think.
I've got one question concerning pipeline processors,
right.
Because these are usually the hard ones to debug when it comes to custom code, etc. Do you prefer maybe the usage of the pipeline tool from Sitecore, because that's a little bit hard to get?
I'll be honest, I tend to go to Visual Studio and the tracing code there at that point, because you get a more holistic view of what's going on in the CPU at that point, and it's just slightly easier to do, I think.
Experience.
And that's about it.
Awesome. Right. Thank you very much, everyone. The slides will go on my blog in the next few days.